In the dry regions of Iran, you can still find unusual structures with enormous earth-colored domes. They are called yakhchals. Yakhchals are often described as ancient Persian refrigerators. People used the cold of winter to make ice, or collected snow and ice from natural sources. The ice was then stored and protected from heat so that it would melt as slowly as possible. But there is one important point to keep in mind. The phrase, ancient Persian, can be a little misleading. The tradition of storing winter snow and ice, for use during the warmer months, goes back a very long time in Iran and the surrounding regions. Simple ice storage pits may have been used as early as the 1st millennium BC, and possibly even earlier. But we do not know exactly when these simple storage methods developed into the large structures that we now recognize as yakhchals. The yakhchals that still survive today were not all built in ancient times. Some date to the Safavid period, between the 16th and 18th centuries. Others were built even later. So the practice of storing ice is ancient, but many of the large domed yakhchals we see today are not. They should not all be thought of as buildings from the time of the ancient Persian Empire. So what exactly was a yakhchal? How did people make ice without electricity or modern refrigeration? And how could they keep that ice through the intense heat of summer? To understand that, we first need to look at the climate of Persia. First, we need to understand where people got their ice and how they obtained it. When we think of Persia, it is easy to picture a hot desert. But present-day Iran has high mountain ranges, broad plateaus, and very different climates from one region to another. In many parts of the Iranian plateau, summers are extremely hot and dry. Winters, however, can be cold enough for temperatures to fall below freezing. This meant that yakhchals were not equally useful everywhere in Persia. They were especially useful in places where people could make ice during the winter or bring snow and ice from nearby mountains. In areas close to the mountains, natural snow and ice could be collected and carried to storage sites. In places where natural ice was harder to obtain, people used the cold winter weather to make ice themselves. So the basic conditions were quite simple. Summers were hot enough to make ice valuable, while winters were cold enough to make or collect it. Some yakhchals had wide and shallow ice-making pools nearby, along with long and high shade walls. People filled these pools with a shallow layer of water, usually about 5 to 10 centimeters deep. Because the water was spread out in a thin layer, there was less water to freeze in each area. The broad surface also allowed heat to escape more easily into the cold night air. The most basic requirement was that the winter nights were cold enough. People did not make all the ice they needed in a single night. Instead, they added a shallow layer of water on each cold night and allowed it to freeze. They repeated this process until the ice became thick enough. The real problem came during the day. If the ice was exposed to direct sunlight, it would begin to melt. To reduce this, a long and high shade wall was built on the south side of the ice-making area. The wall did not make the ice colder. Its main purpose was to block direct sunlight and slow down melting during the day. The basic process was simple. Freeze the water at night, protect the ice from the sun during the day, and then freeze more water on the next cold night. Once enough ice had been made, it was cut or broken into pieces and moved into the storage chamber. At this point, the way a yakhchal worked becomes much clearer. In large domed yakhchals, the ice was not made inside the storage chamber. Instead, ice was made outside during the winter or collected from natural sources such as nearby mountains. It was then carried into the storage chamber. So the storage area of a yakhchal was not like a modern refrigerator or freezer that actively creates cold air. It was closer to a giant insulated icebox, or more precisely, a place designed to store ice for long periods of time. So the main goal inside the storage chamber was not to make the ice colder. It was to make the stored ice melt as slowly as possible. In other words, the key was to slow down the transfer of heat from the hot outside air to the ice inside. To reduce heat entering the storage chamber, much of the ice was kept below ground level. The surface of the ground can become very hot during the day and cool again at night. But deeper underground, daily temperature changes are much smaller. This made underground storage much better than leaving the ice exposed near the surface. The dome and walls above ground were also built extremely thick, often using materials such as mud brick. People did use natural insulating materials like straw, but they did not have high-performance insulation like modern polyurethane foam. So one of the most effective solutions was simply to make the walls very thick. A thicker wall gives heat a longer path to travel, which increases thermal resistance. Thick earthen walls also have a high thermal mass. This means that even when the outside temperature changes quickly, the temperature inside changes much more slowly. By using these methods, yakhchals were able to keep outside heat from entering. One of the most striking features of a yakhchal is its huge conical or domed roof. Because of this unusual shape, it is easy to assume that the dome itself had some special cooling function. But first, we need to look at its structural role. To store large amounts of ice, people needed to cover a wide and deep space. They did not have reinforced concrete or steel frames. Instead, they mainly worked with mud brick and other masonry materials. Arches and domes were well suited to these materials. Their curved shape helps transfer the weight downward through the structure. This made it possible to cover large spaces without modern structural materials. The walls also became thicker toward the bottom, which helped improve structural stability. At the same time, this large and thick outer shell also helped protect the ice from heat. It completely covered the storage space and kept the ice out of direct sunlight. The thick walls also slowed down the movement of heat from the outside to the inside. So the dome was not some kind of special cooling machine. It was a practical way to build a large and stable ice storage space with the materials available at the time. Two ideas often come up when people explain how yakhchals work. They are the stack effect and evaporative cooling. Some large yakhchals had a small opening at the top of the dome. Because of this, a common explanation is that warm air rose through the interior and escaped through the opening. The colder air then remained below and helped preserve the ice. But this idea needs to be treated with some caution. If air continuously leaves through the top, outside air has to enter somewhere to replace it. During summer, that outside air can be much warmer than the air inside the ice storage chamber. So continuous ventilation could actually bring more heat into the yakhchal and cause the ice to melt faster. Evaporative cooling also needs to be considered separately. At an outdoor freezing pool in winter, evaporation could help remove some heat from the water. But that does not mean evaporative cooling was the main cooling mechanism inside the yakhchal during summer. Direct evaporative cooling has a physical limit. The air cannot normally be cooled below its wet bulb temperature by evaporation alone. For example, if the outside temperature is 40 degrees Celsius and the relative humidity is around 10%, the wet bulb temperature is about 18 degrees Celsius. That is still far above the temperature of ice. So even if evaporation cooled the incoming air, bringing that air continuously into the storage chamber could still transfer heat to the ice and increase melting. In summer, the main goal was not to keep air moving through the storage chamber. It was to limit the amount of hot outside air and external heat reaching the ice in the first place. So why did some large yakhchals have a small opening at the top of the dome? There is probably no single answer. Not every yakhchal had the same kind of opening, and we do not have enough historical records to know exactly how each one was used. Modern studies have also questioned the idea that these openings provided ventilation cooling. Some researchers have suggested another possible purpose. The opening may have been used mainly to bring natural light into the interior. Large yakhchals were deep and dark inside, and workers had to enter the storage chamber to store and remove ice. Using fire for lighting would have produced heat, smoke, and soot. A small opening at the top could provide daylight, without adding those problems. Some large yakhchals also had step-like projections on the outside of the dome. These may have allowed workers to climb up and inspect or repair the earthen surface. They could also have provided access to the opening at the top when needed. So it is probably too simple to describe the opening as a kind of chimney cooling system. It may have served several purposes, including daylight, ventilation, access, and maintenance. Even with thick walls and deep underground storage, it was impossible to block all outside heat. So some of the ice continued to melt during the summer. The goal of a yakhchal was not to keep the ice from melting completely. It was to slow the melting enough for winter ice to last through the hot season. For that reason, meltwater was not allowed to remain around the stored ice. The floor was designed so that water could collect at a lower point or drain away into the ground. The large domed yakhchal is the form we see most often today. But yakhchals actually came in many different sizes and shapes. Some were domed, while others were built underground or surrounded by walls. Their design depended on local climate, terrain, the amount of ice needed, and how that ice was obtained. Not every yakhchal had an opening at the top. And not every yakhchal made its own ice in a freezing pool nearby. So we should be careful not to take one feature from a particular large yakhchal and treat it as the key cooling technology of all yakhchals. Despite their differences, they all shared one basic purpose. They stored ice collected during the cold season, so that it could still be used during the hot season. In the end, a yakhchal was not really like a modern refrigerator that actively produces cold air. It was closer to a large ice storage system, designed to preserve winter ice through the heat of summer. The basic idea was surprisingly simple. But the real achievement was putting those simple ideas together without electricity, refrigeration, or modern insulation. That made it possible to store large amounts of ice for long periods of time. And that is what makes the yakhchal such an impressive piece of engineering. Thank you for watching, and see you in the next video.